Hey guys, welcome. If you'd like to support this channel, there are PayPal and Patreon links in the info box below. We got a great one lined up for you today. Spectroscopy. One of my favorite presentations. Let's see who we got on the panel. Who we got on the panel out there?
Me.
Who's me?
It's Syrinx.
Syrinx. Who else we got?
Got Adamiken.
E.
Then we got Lieu.
Hey, oh, he's muted. 1 second. There you go, Flatwood.
Hey.
Hey, give me a radio check. Lost 1, this is lost 3. Are you lost 2, over?
Coming over, ready? Radio, check. 1, 2.
Wow, you're loud. Try it again.
1, 2, testing.
That's a little better. Thank you very much. We can do a lot more admin here. If Nathan's listening, I know he's loving every minute of it.
Oh, good. He's all about sound, is he?
He's all about sound and all about shop talk during live shows.
Yeah. Well, let's continue.
Okay, let's continue. I pulled up OBS earlier today, and everything was good as usual because OBS is pretty sturdy, right? I rarely run into any problems, any glitches, anything, and I shut it down, and then I went back in because I forgot something, and I went back in a little bit later on in the morning, and then shut it down, and then right before the show started, I pull up OBS, update time, America. You gotta be kidding me. Why didn't you update it earlier? So 5 minutes before the show started, I said, oh, I gotta update this thing, man. Let me shut everything down. Boom, update it. Yeah. So there you go.
Yeah, well, we'll see the glitches later.
You ain't gonna see any glitches. Like I said, this thing's a rock. It's an oak tree. OBS. Shout out to OBS out there. Whoever conjured this. Good platform. I like it.
Is there any other?
I mastered it immediately too.
Oh yeah.
I left you guys a hanging curveball. You and I, you know, I was a cluster when I first got. I'm like, what the hell is this?
You needed a lot of help.
Yes, I did.
Well, it was first your equipment, right? That was the first thing.
Don't be talking about my equipment.
It's always about the equipment. You need to have the right hardware.
Oh, here we go.
Oh, now you catch it.
Oh boy.
Yeah.
We got 33 people in. What's up with why 33? I think they muck with these numbers. I'm pretty sure they do.
33 is a good number.
They're mucking with numbers, man. They gotta be. That's more shop
numbers because I am not allowed to post any numbers anymore.
That's more shop talk, so I don't want that. I'm not gonna do that.
All right. Yeah. So.
Good.
We were talking about the weather and having a great weekend here, and talking about barbecues and stuff.
Ain't no barbecue.
What?
Ain't no barbecues here today because it is freezing outside. It's cold. It's in the 50s and rainy.
It's June. Why are you in the wrong numbers?
Hey, listen, it's just what it is. Yeah. In fact, I had to turn the heat on. If winter, then you know what?
Then heat. Sure. Yeah. So no echo, right? Doesn't work.
No, not today. It's too cold. But we don't want to talk about the weather all day. How let's just do it anyway. So in Dutchland, how's the weather?
Yeah, it's really nice. It's warm.
Yeah. How
You
warm?
can walk outside without any clothes.
How
any
warm?
clothes
And
on.
don't give it to me in Celsius either. Before you say
Oh,
it.
yes, I am. Because
No.
I think it's 22, 24.
No, before you say it, convert it.
No. It's everybody lives here in Europe, so
What?
yeah.
Yeah, us normal people use Celsius.
Everybody, everyone doesn't live. Wait a second. You said everyone here lives in Europe. No, everyone doesn't live in Europe.
Yeah, well, most of us, there should be.
Jeez.
Most Europeans do. It's 75.2.
Most Europeans do. That's profound, Adam.
There's a baller response, isn't it? A total baller response.
It is a baller response, exactly.
Oh, he told you the degrees.
75. That's not bad. How about the humidity?
Oh, come on.
That's gonna vary, right?
I don't know. Are we going to go that far?
Well, that makes a big difference because 75 degrees with 80 or 90% humidity is not good.
Right. So because we're in Northern Europe and nice sunny days are such a rarity, don't care about the humidity. If the sun's out, it's a blessing.
Yeah.
I got you.
The beautiful day is about the same, and I don't think that's as good as it gets.
It's as good as it gets, right? Because it's not too hot, even though it might be high humidity. I got you. I'm tracking with you, sure. Yeah.
Yeah, and it's a whole search to go after that.
All right, well, hold on. Let me get my first alert. Weather. See what the dang temperature is here.
Well, we 60 degrees Fahrenheit at the moment.
See, that's a little chilly. And guess what we're at? 60 degrees. How about that?
60 degrees of what? Angular? What?
60, yeah, it's angular momentum.
60, I mean, that doesn't mean anything. You need to say the value, right?
I said the value.
Yeah, the terminology, that is
60 degrees Fahrenheit.
oh, Fahrenheit. Yeah, good. Remember when you had that conversation last time with Thor and the other value? Do you need to sort of get on one sort of value?
Oh, you're talking about, yeah, when you're talking about comparing apples to apples, you always have to reconcile units of measure. You know, so all you have to do is a little dimensional analysis, and you can get it's just a run of the mill calculations to. But you always have to do that because you'll breed confusion, serious confusion.
Yeah, like I was totally confused.
Yeah, like you was. You know, Charles Flat Earth Math, that numpty dipshit, used to do that all the time as a math teacher. I used to always tell him, why don't you just get the same units? Use the same units. Why bring in different units of measure? Why do that? Because you're a numpty. That's why.
I hope that he doesn't teach his kids that way. Because
he does.
Also, at school, it would get me really frustrated.
In fact, yeah, that would just breed confusion. And that's going to be, I'm going to highlight that during the presentation because I think that I think they do it purposely so it does breed confusion. Follow this scenario. If you're let's say you're in academia, right? And you got a somewhat technical subject, but you want to pull the wool over everyone's eyes.
Mm-hmm.
I mean, collectively, I'm not talking in one single university. I'm talking the overall concept. You want to pull the wool over everyone's eyes. So you put out some, I don't want to, they are contradictions, but no one calls them contradictions. But anyway, it's sort of gray areas. And I'm going to point those out. But those gray areas are spread so far apart that it allows them latitude to work with their fairy tales. But there's another aspect to this. If you're like egocentric type of person, you're in university, you're with your classmates and stuff, maybe it's a higher level, and they talk about some kind of technical subject, and you realize in your mind that it's a little bit iffy. You don't really understand it. It doesn't sound all that right, but you're hesitant to ask any questions because that'll show everyone, including the professor, you don't know it. You follow? So you don't say anything, right? You just stay confused. You say, the heck with it. I'm not going to bring it up. I'll be embarrassed. Follow?
Yeah. People want to be in sort of certain sort of comfort too, right? They
Sure.
don't want to stand out. Yeah.
Sure, they want to put an air, especially at university. You don't want to show your classmates you're numpty, right? So you're figuring, everyone looks like they understand this topic. I have a couple questions here, but I'll shut up. I'm not going to say anything because that'll ruin the appearance, right? Follow?
Yep.
Yeah. Is it a profound thought, or I'm a idiocy that I've not figured out? Paranoia control you in that.
Right, and I think that that's used. This is some serious conspiracy stuff right here, people. This is getting... I do. I think that that's used.
You're treading on thin ice, man.
Yeah, I'm going deep on this one. This is a deep dive.
Go down one of the rabbit holes. What does it end up in?
I didn't plan it. It strikes me as that. And when we go through the presentation, I'll go ahead and stop at the places where they're obvious. You're going to see how obvious they are. They seem subtle and like, that's not a big deal. I think it is. So I'll point those out here. I just love this presentation. If there was a couple presentations that I could do, like every single time out, I would choose the Creator versus Atheism, because I really enjoy that one, and this one, Spectroscopy. I look forward to it. There's something about it. Something's very attractive about this for some reason. Maybe I'm a lunatic.
Lunar,
Baby.
moon.
Not a lunatic.
Yeah, but it has to do with the moon, right?
This doesn't have to do with the damn moon.
Yeah.
just
Look
like-
at it. It's coming from moon and being crazy, moon crazy.
It just lights up your life. John.
Yeah, it lights up my life. Where's 10th when you need him?
Well, the moon is also a light.
Yes.
So being a lunatic sort of lights you too.
I wonder if they ever did any... I didn't look that up if they did any spectroscopy on the moon.
I'm going to have to butt in.
Go ahead, butt in. Go ahead.
It's spectrochocoloscopy.
Oh, I knew it.
Come on, let's get it right.
It's Spectra. There's so many names, the Baltards. It's hilarious. I highlighted them when we did the first presentation here. I think Toady, I see that numpty. He's back out here. Toady, you numpty dipshit. Right? He called it spectroscopy. In fact, that's what the title of the first show was. We titled it, right? Betty, spectroscopy.
Yeah.
And
I thought it was spectroscopy.
it is spectrochocoloscopy. It is, okay? But if you listen to the Baltards, they will butcher this. It's hilarious. I find myself, too, if I keep on saying the wrong thing, like spectroscopy, that in my conversations with others, I'll use that same word and screw it all up. I was talking to my daughter about it. It was a few months ago, the last presentation we did, and I said, we were talking about and I called it spectroscopy. And I was like, oh, good. I got to stop doing that. Or it's with a number of them. Because a lot of people call it the double split experiment.
Oh, yeah.
And I used to make fun of them a lot, but then I catch myself because saying it a lot, you say it then. It's a bummer, man.
It's not the double split? What?
No, it is.
No, that's a different subject.
Is that coming up soon?
What's that?
Oh, I think that you haven't talked about the whole quantum mechanics Since your name is Quantum Eraser, I think that would come up sometime.
A quantum mechanics presentation again? You want another one of those?
Oh, well. Oh, maybe we should go to the God proofs first.
Yes, the creator versus atheism is coming. Yes. Yep.
Never done this on this channel, I think. So yeah,
it's
be nice.
It's TBA, to be announced. So it's coming. We're gonna drop anchor. Now, I guess people have caught on that I'm dropping anchor in these topics now. I won't only do one show. I'll do maybe 2 or 3. So that's the new policy going forward. So that you're going to see this presentation again. You might see it 3 times. You might see it in BALLBUSTERS, and then I might do it again.
What? The spectroscopy one?
Like what?
I can't say it way Adam says it, because if I do that, I will never get it right.
This aggression will not stand.
Well, what else does not stand, Nathan says, that you started without him.
Yeah, I seen it. What's up, Nathan? Yeah, you may start now. That cracks me up.
Nathan is ace.
Yeah. All right. So we got everyone's getting seated in here. Maybe about another 5 minutes or so, we'll get into the presentation. But first, before we get to that, we got to know.
Oh God, no.
we got to know what Adam. Now I'm getting an echo.
I will go on mute once this is out.
Once. Just keep on going on mute. So we got to know, Adam, what you have. Oh my God, she's still doing it. Let me get in here. Is that you, Betty? Yeah, it's you. Yes. And she goes on mute real quick. Yes, and it echoes. So, without further ado, Adam, the Adam Meakin, you know where we're headed with this. What did you have for vittles today? That little sucker's on mute. He didn't come up. I'll bet you he's eating right now. You better get back to that mic.
Sounds delicious, whatever he had.
Well, it made him silent. That's for sure.
Was another Kit Kat?
It was a Kit Kat.
I think he sneaked out.
He did sneak out. He's busted. He's called out.
Hey,
Yeah.
QE, you know, we got into that a little bit today, the double slit, and we got into the creator over atheism
Where at?
and evolution.
Really?
And Nathan's show today at the end, yeah. I was hoping you would come on.
Sorry, man. I'm in a rut. I'm in the go to bed really late and wake up late. I'm in that rut. I can't get out of it. It's driving me nuts. So, sorry about that.
He's getting old.
Hey. That'll be about enough. Adam, we're going to start this presentation, man. And we want to get your vittles in here because everyone comes here for what you had to eat.
Yeah, it's usually very fancy, so. No.
He's stonewalling me.
Yeah. He probably, when you want to round out, he will sort of come around.
We ain't playing that. Oh, that shouldn't be up. You get out of here. All right, let's take that down. Adam, I can only delay for so long.
I think that we're not going to get it now. Wait for it at the end.
Okay, let me... No. All right. We'll just relax here for a couple minutes. We're just waiting on you, Adam. No problem. You're just holding up the show. No stress. There's no pressure, Adam.
Are you really going to do this?
A stinker.
How's that for a sidekick, huh? Just leaves you in the middle of.
Well, he's probably right into tea. He's probably in it right now.
Oh, he was right on cue when we started. Just before you went away for the show to start, he came in. So that's
Yeah.
important because we were having a sort of a conversation about stuff, and then we have to sort of abruptly sort of stop it because you come in with "Hey guys," right?
Oh, right. I just barrel, show up like Bob Uninvited Hope, just barrel my way in.
Yeah, we have the best conversations when you are sort of starting the show.
Well, that's great. Thanks. Why don't you share it with the audience?
Yeah, I am. People
Wait a second, I just realized now. So now we know that when the show starts, he disappears.
Yeah.
No. Oh, I see what you're saying. I got you,
Yep.
Neil. All right, I got it now. Every single time from now on, when I start a presentation, I'm going to stop and say, "Hey, Adam."
Yep.
Well, he couldn't do that last time because we had an open chat, right? So,
Right.
And he was there anyways.
Yeah.
Although he came in late, I think. Yeah.
All right.
So are there any new things that you have incorporated into the spectroscopy presentation?
I did not. I didn't have to do it. I reviewed it. Like I said, when we were talking yesterday, I went and reviewed it yesterday, and I said, no, this is good to go. I don't have to do anything with this. Nope.
No new research, no new scientific papers that come out and need to or review and other things.
Nope.
Oh.
This is pretty well established. It's not going to be, we're not on the cutting edge here trying to figure out how much B12 you need to cover arteriosclerosis. This is spectroscopy. It's ingrained. It's established. It's solidified. Retro Bell, thanks, man. Eagerly awaiting the nail spike Louisville Slugger. Comes every day, dude. Every single day.
Yeah, he's swinging, but he's not hitting.
Hey.
Oh, sorry.
He's swinging, but he's not hitting. Somebody garnish her wages.
I do this for nothing,
Oh.
All right, let me put this down. Adam, sir. It's not going to happen.
No.
Oh, you know what? Before I start, let me go in and share so you guys can watch. Right? So you don't have to watch the live stream. Let me do that. Thanks for reminding me.
Yeah, I'm good at that. That's why you have me. Huh?
So sorry, John. Would you do live stream for us?
Did it do that? It did. Hold on a second. I picked it. Go live, dude. Oh, there it is. So you guys see that?
I do.
It's on.
All right, mic discipline, guys. We're going to head into it. Oh, that's the wrong one. Okay, there you go. There you go. Little technical issues. We got it, though. Aha! Gotcha! All right, spectroscopy. I almost said it. And I did say it. Spectroscopy! Yeah, this is, like I said, it's one of my favorite presentations. It really shows, if you understand conceptually, spectroscopy, it breaches many areas, right? And it'll shine the light, no pun intended, on the areas, and they can't escape. There's no escape out of this. So that's why I love it so much. Right? I almost said it again. Spectrochocoloscopy. There you go. basically is the interaction of light with matter, specifically with respect to emission and absorption of radiation, right? Basically, that's just what it is. Nothing special, right? It's cut and dry. We don't need to listen to pages of definitions for it. That's what it is, right? Its basis is founded in quantum mechanics. Like I said, the entire enterprise is based on the quantization, extra T there, of energy and quantum mechanics. Now, each element has its own unique, distinct fingerprint, governed by the number of electrons in their respective shells or energy levels. Now, give me a break with the diagram. All right, this is not how it is. It's just to depict it. Okay, so we can sort of kind of understand it. Basically, it's a cloud. There are no orbits. There's nothing orbiting here. I mean, people talking about orbits, it's preposterous. And you're corrected at university level, let me tell you. They'll correct you right away. So anyone talking orbits, they say orbits, you know they've never been to university and discussed this topic. They're just looking at pop science. But I digress. There's going to be a lot of digressions here. Just to let you know. Just to warn you. So essentially, you got the ground state. You got the electrons. We're only using one here today. Keep it simple. Excited state. And what happens is, right, when stuff gets hot, like everyone knows stuff gets hot. When you set it on fire, you see the glow. You know, solids, they glow, right? What's happening here is that these atoms are taking in this energy, and the electrons are jumping up into higher energy levels, right? This electron right here, he's going to jump up. And like I said, there's only one energy level, but in reality, most atoms, there's many energy levels, right? And they give off different colors. Whenever you start burning something, it gives off one color, and the hotter it gets another color, and the hotter and hotter it gets, it changes colors, right? Everyone's noticed that. That's what's happening here. But you see, atoms like us endeavor to persevere to be in the relaxed state, right? I'm retired. I endeavor to persevere to be in the most relaxed state possible. Right? And so do atoms. So does everything. They want to relax. So what happens here is when these electrons are up in these high orbitals and they're starting to lose energy, these electrons endeavor to persevere to get back to the ground state. Right? And what they do to get back to the ground state, like right here, they'll jump these energy levels. Now, this is very important. This is at the base of quantum mechanics, right? It's called the quantum leap. What happens here? Let's say we got an energy level. Let's just go with the N4. You got electrons in these outer shell energy levels. What they do is they do not traverse the space when they're going back to the ground state. They do not traverse this space back to the ground state. I know that sounds crazy. They call it the quantum leap. And we know that they don't traverse this space. They just boop, pop in here. Boop, pop in here, right? We know that. Why? You see this little thing down here, this emission line spectra? That's how we know it. Because you're getting distinct lines at distinct energy levels. You see, if this electron came, traversed this space from here to here, here to here, this would be a smear. You see it? No pun intended. You guys follow that? Hopefully you do. Okay? It's quite beautiful, and there's the evidence right there. It would smear. But no, they don't. There's distinct energy levels, and that's what you're getting right here. Hope everyone gets that. If you understand that, you're well on your way. Any questions about this, just go ahead and put them in BALLBUSTERS text chat, and I'll get to them at some point. after the presentation, probably after the total presentation today. But this is very important. This is the basis of spectroscopy. Now, there are three main types of spectra. I'd be asking these questions to baltards, right? Especially if I hear anyone even whisper spectrochocoloscopy, right? My first question is, what are the three types of spectra? I would say I asked that question to over 250 people in the last 3 years. One or two got it right. That's how you know they're pretender clowns right off the bat. Just real quick, what are the three types of spectra? They don't know what they're talking about. They don't know them. Here they are. You got continuous spectrum, you got an absorption spectrum, and you got an emission spectrum. Now, these two are line spectrums, right? This has become very important here over the next few minutes. Okay? Continuous spectra are produced by energized solids. You see this one up here? Energized solids produce this. Now, plasma with caveats. The plasma has to be contained. Let me say that again. A plasma will produce a continuous spectrum, but it has to be contained. That's the caveat with plasmas. The last two, the emission and absorption line spectra, are produced by gases. Gases, this is very important. That's why I'm slowing down. This is going to have far-reaching effects. So, again, continuous spectra, the top one, are produced by energized solids, right? They're vibrating real fast. If you get a solid really hot, it vibrates real fast, and it blurs these lines out. When the electrons drop down, there's many electrons, trillions upon trillions of them, right? Jump in energy levels, and they smear. You can never get, anything other than a continuous spectrum. That's why it's continuous. But emission and absorption lines are specific to gases. That's very important. Hopefully there's no questions there. I even stop here. Key learning objective. Gases only emit and absorb in bands. When I say bands, I mean lines. Right? Lines, bands. Gases only emit and absorb in bands. Very important in our discussion today. All right. Let's get to cases. Atomic emission spectroscopy and atomic absorption spectroscopy, respectively, are A-OK. There is nothing wrong with anything with these two disciplines. They're the same discipline, right? There's nothing wrong up here. I'm not here to indict this. I know better because it's right on time. It's as right as the rain. Those two are terrestrial spectroscopy. No problems, right? Against this monkey. This is the problem. This has nothing whatsoever to do with these guys. Nothing. All they do is take the name, right? Because they know this has veracity out the yang. They take the name and place it on their friggin' fairy tale, right? In some feeble attempt to transfer veracity, that's all they do. So this is what I'm here to do today. I'm here to indict this guy. Astronomical spectroscopy, stellar spectroscopy. I'm going to show you the little trick that they pull. Well, there's a couple of them, but it's one main trick. So let's make that perfectly clear. There's nothing wrong with terrestrial spectroscopy. Nothing. Zero. Say, okay, this guy, this is the monkey. This is the one that's adulterated right here. Like I said, terrestrial spectroscopy, we get atomic emission. This is flame. This one's an inductively coupled plasma electrothermal graphite furnace. You see what this is, folks? This is a machine. Huh? It looks like it's a closed system. Doesn't it? That's the way it looks to me. Huh. That's very interesting. I did go through this in the first presentation, all the steps. We went through all the steps and how the process works out. If you need, I'm not going to do that today. If you need to, just go back to the first presentation and I go through it and explain it. Same thing with atomic absorption spectroscopy, right? This one right here, we got another machine down here. This looks like another closed system. Doesn't it? Shocking. So those two have a lot in common here. Looks like they're in a closed system. Looks like this might be a highly controlled motif. That's the way it looks to me. Right? And like I said, I go over the process in the first presentation, so go back there and you can go through it. As opposed to, guess what we got here? Celestial or astronomical spectroscopy. This doesn't look like a closed system, does it? This is an open system and not controlled. All the unknowns and millions of potential confounding variables between you and specifically the sun. This is the McMath Pierce Solar Telescope at Kitt Peak National Observatory. Right? You see the issue already. I really don't have to go much further. It's the difference between this and is that the same as this? Or this? Huh. But they both have the same name on the end, spectroscopy. They don't look the same to me. You? No, they're not looking the same. Big problem. Number one, belly laughing train wreck. You see the elephant in the room problem. I just showed it to you. And this is merely just one. Actual spectroscopy, that's AES and AAS, closed system, highly controlled. Celestial spectroscopy, open system, and no control whatsoever. These are two different animals. Just on the surface. It's just another feebly contrived, clumsy Dunning-Kruger bait and switch. The clowns say spectroscopy, using the veracity, like I said, of actual spectroscopy, terrestrial, to give credence to the fairy tale celestial spectroscopy via Elmer Fudd linguistic association with the word spectroscopy. That's all it is. It's a simple doofus equivocation fallacy, right at the core. And a Mr. Magoo false equivalence fallacy. That's it. That's what it is, people. There it is. Those sly dogs, right? Why hasn't anyone called these people out yet for this? You don't hear any of this. I don't. That's all it is. Unbelievable. Second belly laughing train wreck. Let's check this out. We're not getting to the meat yet. This is just periphery stuff right here, folks. We're going to gnaw into the meat here in a few. Just relax. So we got folk called Peter Solo Astrophysics and from Caltech Cool Cosmos. Let's read this together. Astronomical spectroscopy is used to measure three bands of radiation: visible spectrum, radio, and X-ray. While all spectroscopy looks at specific areas of the spectrum, different methods are required to acquire the signal depending on the frequency. Ozone and molecular oxygen absorb light with wavelengths under 300 nanometers, meaning that X-ray and ultraviolet spectroscopy require the use of satellite telescopes or rocket-mounted detectors. Uh-oh. That's a problem, isn't it? There's another problem here before that, but I'm not going to show it just yet. Right? Radio signals have much longer wavelengths than optical signals and require the use of antennas or radio dishes. Infrared light is absorbed by atmospheric water. Atmospheric? What? That's a contradiction in terms, isn't it? Atmosphere. Atmo, air. Air meaning gas. Sphere meaning shape. Gases have no inherent shape, folks. But I digress. Infrared light is absorbed by atmospheric water and carbon dioxide. So while the equipment is similar to that used in optical spectroscopy, satellites are required to record much of the infrared spectrum. See, they gave away the game a little bit here. If you haven't seen these presentations before, there's a game release here. But I'm not going to release it just yet. We'll just take it at the surface. So, Since X-ray, ultraviolet, and infrared spectroscopy require satellite and rocket-mounted telescopes, that is, they need to travel into a second law of thermodynamics violation, aka telescopes in Narnia, they're shit can. We can just drop them right now. Since our focus is on the sun, radio spectroscopy is also shit can. So we could take all those out right now. You see, section summary. When the incoherent hordes of clinical-level Dunning-Kruger pretender clown wiki Discovery Channel parroting spinning Baltard space monkey window lickers respond with spectroscopy or spectroscopy when challenged with, how do you know what the sun is made of? You can now laugh and uncontrollably in their crayon-munching faces. Just with that, we didn't even get into the particulars just yet. Just the surface stuff. You can still laugh at it. And I could stop right here. But I won't. Where's the fun in that? Key learning objective again. Gases only emit and absorb in bands or lines. Right? Why do I keep saying that? There's a method to my madness. Oh, we got another belly laughing train wreck. Let's see what we got here. Huh. From NASA. This is quite troubling. The spectrum of the sun appears as a continuous spectrum and is frequently represented as shown below. Right here. It is, folks. This type of spectrum is called an emission spectrum because what you are seeing is the direct radiation emitted by the source. In the case of the sun, light is emitted at almost all energies in the visible spectrum, which is why you see all the colors in the sun spectrum. Right? Sound good? The sun's absorptive spectra. This is taken by the telescope I showed you above, the McMath from Kitt Peak National Observatory. All right. Question. How in the flying Fukuyama can the sun give both a continuous spectra and an emission line spectra, por favor? Now, this may sound pedantic, and it's not my main point. My point here is that there's no precision here. They lack precision. Remember we discussed before the presentation about the gray area? So this is one of those gray areas where it opens up wide and allows their fairy tale branches to escape. I'm telling you, this is one of them. So how can you say the sun appears as a continuous spectrum and this is the absorption line spectra? Well, which is it? You can't have the sun given both a continuous spectra and an emission line spectra. You can't. Does the sun have its own no-atmo day too? Let's check this a little further. From NASA again. When the light leaves the surface of the sun, it is very nearly a continuous spectrum. Huh? I thought you said up here it was a continuous spectrum. The spectrum of the sun appears as a continuous spectrum. That's what they said. This is NASA. See NASA? But wait a second. Down here, when the light leaves the surface of the sun, it is very nearly a continuous spectrum. Well, now it's very nearly. Unbelievable. However, as it passes through the sun's atmosphere, that's a contradiction in terms, paradox, and a second law of thermodynamics violation, but I digress. I told you about the digressions. I'll start over. However, as it passes through the sun's atmosphere, gases present in the atmosphere absorb specific wavelengths of light. That's interesting. Leaving the pattern seen in the spectrum above. Yeah, that pattern right there. That one. That's the one they're talking about. Not the other one. By studying those lines and matching them to the known lines from the elements, astronomers are able to determine what gases are present in the sun's atmosphere. Huh, really? So make up your mind, NASA. I pulled them both out so you could see them. The spectrum of the sun appears as a continuous spectrum. And then when the light leaves the surface of the sun, it is very nearly a continuous spectrum. Well, which one is it? Very nearly or continuous? As I said, this isn't my main point. This is just that gray area that they superimpose over this that allows them their fairy tale reindeer games. Okay? Not a biggie. I'm not all that concerned about that one up there. I just wanted to point it out for you. This one's quite interesting. So this is by Hernshaw, The Analysis of Starlight from Cambridge, and Francis Jenkins, Fundamentals of Optics. Listen to this closely. Hot, solid objects. See this solid? Remember we talked about continuous spectrum above? Hot, solid objects produce what? Well, they produce a continuous spectrum, like we went over above. Hot gases emit light at specific wavelengths. We talked about that. Remember my key learning objectives. Gases only emit and absorb in bands or lines. That's what they're saying here. And hot solid objects surrounded by cooler gases show a near continuous spectrum with dark lines corresponding to the emission lines of the gases. By comparing the absorption lines of the sun with the emission spectra of the known gases, the chemical compositions of the stars can be determined. What? Does anyone see the hairy T-Rex in this? I can't look at the chat. Anyone see a problem here in Shangri-La? Hot solid objects produce light with a continuous spectrum. Hot solid objects surrounded by cooler gases. Is the ball of hydrogen gas, the sun in the second law of thermodynamics violation, a solid object? See it now? They're talking about the sun right here. A hot solid object surrounded by cooler gases, right? So, obviously, that hot solid object, the solid must be the sun. Oh boy, the tangled webs you weave. This isn't the elephant in the room yet either. I'm just pointing out the lack of precision here with professionals. From Cambridge, upstairs you have Caltech, NASA. This is a joke. I hope everyone sees it, right? But like I said, that's not the coup de grace just yet. Ladies and gentlemen of the jury, you're witnessing a convoluted gaggle screw of epic proportions. Oh, by the way, if it's not a solid, is it a gas? Right? If so, then number one, how in the flying Fukuyama are you getting a continuous black body spectrum full of a ball of hydrogen gas when gases only emit and absorb in bands? How you doing that little trick? See, this is what you get for not being precise. Remember, and again, my key learning objective, gases only emit and absorb in bands. No question here. There's nothing you can do about it. Number two, how in the flying Fukuyama are you getting a ball of hydrogen gas in a 10 to the negative 17 torr vacuum without bludgeoning the second law of thermodynamics to a bloody lifeless pulp? And the same goes for plasmas, like I identified in the beginning of the presentation. If you thought all the above was a rootin' tootin' cluster gaggle of double-speak horsepuckery, then somebody hold on to these ball-tards beers, because they got something for you. We're going to get to the meat of it, right? And I can drop anchor here, and the prosecution can rest his case. This is the meat. Listen closely. From Lumen Learning. The dark lines in the solar spectrum thus give evidence of certain chemical elements between us and the sun. What? Absorbing those wavelengths of sunlight. Because the space between us and the sun is pretty empty, astronomers realize that the atoms doing the absorbing must be in a thin atmosphere of cooler gas around the sun. Oh, really? Give evidence of what again? Por favor? Well, they said certain chemical elements between us and the sun. Aren't we attempting to find out what the sun is made of? Not the stuff between us and the sun? You think? This is the silver dagger, folks. It's just that simple. They're talking about finding what's between us and the sun, not the sun. What the heck is going on here? Right? This is the full Monty, folks. This is it. Again, I could stop right here. This is the main thrust of the presentation is right here. I hope everyone sees it. I don't think I could break it down any further. I will try to here in a couple seconds. This is big problems, folks. Big friggin' problems. That's what you get. Can somebody please tell me what in the flying Fukuyama is going on here? When the question is, what is the sun? And these guys are telling us what's between us and the sun. Two different things. It's as simple as that. All right, let's take a look at this. So like I said, there are three types of spectra. You got continuous, absorption, and emission. Right, we're going to take a look at these two over here. This is pretty funny, right? They put you out in space. And obviously, they're saying that this little light bulb up here is analogous to the sun. Well, you got a metal filament in here. That's a solid. Again, is the gas a solid? Anyone? Yeah, that's what I thought. So what they're trying to say here is, like I was portraying above, is if there's nothing between you and it, this solid, and it gets really hot, you're going to get a continuous spectra, right? Everyone understand that? Let's go over to the right over here. You get an emission spectra when there's nothing behind the gas. Now, this is a second law of thermodynamics violation, folks. Just want you to know. However, conceptually, right? This works in actual emission spectroscopy, but it's inside a container, right? So this follows, but this diagram doesn't. But I digress. So this light right here is radiating this cloud of gas in a fairy tale second law of thermodynamics violation, and the gas gets hot, and then it emits. Now remember from my key learning objectives, gases only emit and absorb in bands, right? So guess what you're going to get? You're going to get an emission line spectra right here with those bright lines. No problem. So let's cut this off. We're going to cut these two off. Don't worry about these. We're concerned with this middle guy right here. This is how you obtain an absorption line spectra, right? You have a second law of thermodynamics violation, fairy tale gas in a vacuum right here between you and that continuous light source, right? See it? And you get an absorption line spectra. They're saying that it's from the atmosphere around the sun. That's a bunch of friggin' malarkey. We're going to tear that apart just here in a few minutes, but I digress. Let me ask you a question. Let's say between you and that continuous light source, that fairy tale second law of thermodynamics violating gas is 80 million miles away from you and 10 million miles away from what they're portraying here, the sun. Are you going to get the same absorption spectra down here? Yep. Let's say that this second law of thermodynamics violating fairy tale gas cloud is 50 million miles away from you and 40 million miles away from this continuous light source. Are you going to get the same absorption spectra as you got previously? Yep. Let's say this second law of thermodynamics violating fairy tale gas cloud is 20 million miles away from you and 70 million miles away from the sun. Are you going to get the same emission or absorption line spectra that you got the previous 3 times? Yep. Let's say this second law of thermodynamics violating fairy tale gas cloud is 3,000 miles away from you and 92.7 million miles away from this. Are you going to get the same absorption line spectra? Answer, yep. See it? Everyone see it? Hopefully. If you don't, I'm sure I'm going to get questions on it. Now, let's head on to the cool thing gases around the sun. Frigging where? The photosphere, that they call it the surface, gases don't have surfaces, by the way, is said to be 5,700 degrees Kelvin. Oh, by the way, there's a built-in second law of thermodynamics violation, but I digress. So it's said to be the photosphere is said to be 5,700 degrees Kelvin. The sun's atmospheric layers, the chromosphere is said to reach 500,000 Kelvin and is 10,000 kilometers thick. Does that sound thin to you? The corona is upwards of 10 million Kelvin and is 5 million kilometers thick. We're just going by their narrative now. I'm not making this up. Their story. I'm pinning them up against the juror's chair and prosecuting the daylights out of them. Does this look like it's thin? You wouldn't think so, right? Also, you see the second law of thermodynamics violation. Surface is 5,700 Kelvin, 500 Kelvin, 10 million Kelvin. You're getting hotter as you're going away. Right? This is tantamount to standing next to a bonfire and it gets too hot. You move back 100 meters and you spontaneously combust. That's exactly what this is saying. Let's go to Rochester Institute of Technology. Thin gases emit light of only a few wavelengths. We call this an emission or bright line spectrum. If there is a source of light behind it, like we talked about above, a thin gas will absorb light of the same wavelengths it emits. We call this an absorption or dark line spectrum, like we discussed above. Here we go again. Like I said, is it thin? 10,000 kilometers? 5 million kilometers? Is that thin? I guess it's relative, though. Unbelievable. Are the atmospheric layers of the sun cool or cold? How about thin? Neither, right? Neither. So, let's see what we're going to do here. If you think I'm making all this up, right? I'm going to allow Professor Vaught from New Mexico State University speak and hammer every single one of my points home. How would you like that? Sound like a good idea? You know what? Before I do, let's take a break because I've been going for a while here. Let's go ahead and take a break, and before we listen to Professor Vaught, let's get what some of the thoughts from the panel. How about that? Good. Is anyone still out there? Or am I talking to myself?
I'm alive.
Questions, comments, or concerns? Adam, what you have for dinner? What you have for dinner, man? Hold on.
That's why I didn't nip off, bro. I'm so sorry. But and there was no way I was going to bring it up on a tray. It was too nice. So we had a nice Greek feta and olive salad, bit of fresh bread. You'll like this, Betty. Croquettes, 2 types, easy and plain. And then I just had that with a nice fillet steak. An English mustard, obviously.
An English mustard, obviously. Is that what you said?
Yeah.
Freaking hilarious.
Other than that, a simple meal tonight, mate. But I had to go and I looked at it and thought, oh, I'm not eating that on my lap. Apologies.
Go ahead.
On to the spectroscopy. For me, the profound thing is what produces a continuous spectra. I don't know if you mentioned plasma, and I saw as you were discussing the different types of terrestrial machines and the way they work. Standard ball of response is it's a ball of plasma now. Now it's not accepted that it can be a ball of gas, ball of plasma. I don't know if you skipped over that bit or been missing it. But that's one of the bits. It can't be plasma either. That I think relevant.
Is that it?
Oh, I was waiting for you to respond.
I
didn't know if you got food in your mouth.
I do.
Well, that was one bit then. I mean, the fundamentals is that absorption spectra, where their model that absorption has to occur, and where in reality that same absorption pattern is described to us. That it's the hydrogen and helium missing that they attribute to excuse me, what did they call it, the atmosphere of the sun, hence the missing bits. But actually you don't know a lot about up there, but some of the claims that were given is that at the highest reaches we only have hydrogen and helium, and I think, as you demonstrated, that absorption spectra can be generated from anywhere between here and there. So in their model, there's no validity to that absorption. Hence, I think why they're claiming you need to go higher. And I'll probably come to that nonsense later. But that's the other main thing, that just because you've got this absorption spectra, that doesn't validate anything other than there's been some absorption between here and there.
Yes, sir. And I did talk about plasmas in the beginning. Let me tell you something. If you look at through these topics, Mike Discipline out there, I'm hearing some echoes. If you go in and say, just in any search engine, and type in, what is the sun made of? You're going to get a mix. It's hydrogen and helium gas, right? It's plasma. It's gas and plasma. There's no precision here. Even the big guys. I'm not talking about Wiki. I'm talking about, universities, established academia. They're even screwing it. You even seen it up above where they talked about the sun as a solid. What? Right?
Well, that's the contradicting statements again, isn't it? Things we know. What do we get a solid emission from? A full spectral emission from, is solids. Yeah. And then we're saying that thing that we're getting a full spectral emission from is not a solid. So it's because you're dealing with what's in the sky. It's not there's nothing exact to it. But you're trying to make leaps of logic, but your leaps of logic are contradicting yourself in the model you then describe in its most fundamentals, i.e. emission spectra, but it's made of gas.
Yes, and I talked about that being the lack of precision. I mean, it's almost clumsy. You'd expect highly precise. You know what I'm talking about, Adam. Because how many times were you preached that about precision and accuracy? Right? If you had a penny for every time they told you that, you'd be a rich man, wouldn't you?
Oh, and they made me do it.
Yeah.
Here's the.
Yeah. I got sick of hearing it, and I'm showing you right now that there's no precision here, and that's why I said that allows that gray area where they can play their little reindeer games, right? And no one's going to ask any questions. Who's going to challenge a professor on this? Not too many people are going to challenge him or her. It's not going to happen. I already know this. I already been in there. Except if I go in there, I'm going to, as a student, because that's just how I was. If I didn't understand it, I don't care if I was embarrassed or I was well beyond that point. If I didn't understand something, my hand was going up, right? The professors didn't mind that. My classmates hated me. That I could hear as soon as they start talking about a subject, they'd look over, right? And they'd see the look on my face. They know something was coming, right? So all I'd hear is sighs. I'd look around when I asked and just people rolling their eyes. I don't really care. I do not care about your feelings. I'm going to understand this, right? I'm backing up the Brinks truck. I don't care if I'm embarrassed or not. I don't understand it. And I'm paying you to teach me this. You're going to explain it. Because if there's a contradiction in here, it's not making sense. You're getting up against the wall. No, I didn't put him up against the wall like rudely. But I stated all my questions. I had thousands, millions of questions, right? Follow? But that usually doesn't happen. I'm just telling you from experience, it doesn't happen. So,
what age were you there at?
I was a non-traditional student. So when I started university, I was 28.
That makes it a little
explains a lot.
easier, doesn't it?
That explains a lot. Yes, it does.
I don't mean that in a
I know you don't.
way. I mean genuinely. I mean that explains a lot. You've left the comprehension system a long time before and come back to learn something.
Yes.
I don't even think when I was starting university, I was there to learn something with a mission that you would have gone to university to do with a purpose. Kind of stumbled in it as the path of growing up. And you're taught not to question. You're there to learn and probably paid a lot of money to do it. Or, you know what I mean? So you're going to get your money's worth. I don't think that's necessarily a youngster's way of viewing it. So it's a lot more. I think if I went back now, I'd be a nightmare.
You'd be a nightmare, right? Yeah. Betty, you were going to say something? You wanted to add something?
Yeah, the same thing that Adam said. You were away for a while, you came back, wanted to learn something, and then you don't take bullshit, and you don't care to stand out because you already stood out in a sense.
Yes.
Right? So you don't care, right? You came there for a goal and nothing else, not to fit in. And I think they get the younger ones because they know that they are sort of malleable because they want to be not standing out.
No, they don't. They don't want to be in the class. They want to be out partying. See, this is where I corner.
That's a thing, but there's also another thing that has to do with don't want to be the brightest because you get sort of smacked at the end. You get sort of preyed upon after school time. You know, you don't want to stand out at that age, so they will get you, right? And they use that sort of.
They could. I don't want to go into that conspiracy. That's some deep, heavy conspiracy stuff in there. Most of the professors.
Come on, you were in one rabbit hole. You better stick your head in someone.
Yeah, but most, to be honest, the professors that I've had throughout university were, I had very little complaints. Maybe one or two here and there that I noted. You're what they call rodent. Retired on active duty. But for the most part, these were good people, very intelligent people, high integrity people. That was the rule rather than the exception. So let me just stand up for that. It was very easy to tell. But there's a difference, right? Because I went at 28. I already sowed all my wild oats. I was already all over I traveled the world, right? And experienced many things, and in the military, and got out of the military, and went to university. These were just kids coming out of high school, right? So they were looking, for the exit. Oh my God, this class is so long. When are we get out? Me, I'm taking notes, right? What did you say? Could you repeat that? Right? It's a totally different mindset. Follow? I'm sure that's pretty apparent.
Totally. Were you in charge of getting the brewskis?
No, I did not. No, I told you I was already done with all that. Right? That was I already got the T-shirt and the cap. 18 T-shirts and the cap. Didn't need to. No, I didn't do that. I went there for a mission. Right? It was mission.
Yeah, you were preparing for us.
I was preparing for this right now. Too funny, man. Yeah, it's better that way. I've talked to my daughter about it too. I've talked because I think that's important. You know, coming just out of high school, going to university, you're like, not this again. I'm tired of learning. No, go get those oats sown, right? Then come back, right? And you're more focused. So that's just some advice to the parents out there. If you have kids, don't force them directly in. It's not going to work out well. And it's just going to be like a form letter. They're just going to dreamland their way through. Most of the parents are paying for their kids' education too. So that's another problem, right? My parents weren't paying for anything. And by the way, the military didn't pay either. I paid out of my own pocket. That's a long story. I don't want to get into it. But that makes a huge difference. I'm going to tell you that right now. So all those factors led to it. And I don't want to get down on this. I want to stick with this spectroscopy presentation. All right. Let's get back to spectroscopy. Any questions up to this point? Any questions or concerns? If there's any, if you have a problem with something that I said, something that was confusing, don't hesitate.
Should we unmute some people?
Yes, go ahead. Yeah, we can. We don't want to spend too long. Let's give about 5 to 10 minutes for any. I don't want to go on and go to Professor Vaught just yet. She's going to iron everything out for you. But go ahead.
Because she's a woman?
No.
And ironing? Sort of like...
you caught that, huh?
Mm-hmm. Yeah. Don't do that, because it's not allowed. So I muted Flat Arthur. Maybe he has a question, maybe, or something to add.
Quickly.
He's there. I think he's there. A guy named Free Palestine, maybe.
Yeah, hello.
Right?
I would just ask, do they account for reading for Earth's atmosphere when looking through these telescopes?
You're asking the right question, aren't you? I got a little Weisenheimer in here. I talked to him last night. That's cheating.
This would be the pretend purpose of Hubble, wouldn't it?
Because you said that was Free Palestine, right? Me and him talked last night. You're cheating, man.
Well, the question still stands.
It does still stand. I'm not answering. We're going to get to it afterwards.
Okay.
I just want to go for the concept, right? Remember what I said, that they're not actually... Well, I'm just going to hold off on that because I'm going to conclude and drive it home again. So let's move on.
I've got a quick question on that.
Go ahead.
How do you quantify that compensation?
What compensation?
The Earth's atmosphere. So you'd have to go out there with a known light source, quantify it like that. You're going to adjust for the Earth's atmosphere.
What? Don't ask me. I'm not doing it.
Not by their model, because, like I said, isn't that the pretense of the Hubble? That was the point of putting Hubble up there, to not have to compensate for Hubble to be put out to be fake and just using Sophia. A telescope strapped to a plane. So
the same telescope.
Yeah, they tried to compensate for it and were caught out because, unfortunately, the place they were going to put this telescope to compensate for it violates the second law of thermodynamics and doesn't exist. Hence why they had to called out of doctoring Sophia footage.
Oh, you were on that, huh?
Oh, it was years ago, weren't it? But do you remember that? That was just in mainstream science. That was Sophia attacking Hubble, saying you're just using cheaper grade quality of what we're doing, claiming it's a bendy mirror.
Yep.
So I think they have addressed that point. They tried to fake it, and they got caught out, even by their own peers.
Interesting. I wonder... Okay, is that it? Let me see what I got over here. I want to make sure you guys are seeing this. Yep, it's still good. All right, this is gonna take too long, Betty. Let's just go ahead and finish up the presentation. Okay?
Yeah.
Good.
Yeah. 1, 2, yes.
Yeah, I do, because it's just gonna take too long. So what I did was, you guys are gonna have to look at the people in Discord on the panel. They're gonna have to look in on the YouTube stream, because I can't share 2 screens, and I want you to be able to listen to Professor Vaught here. So let me put this out over here. I'll put it out there for a minute or so until you guys catch up.
I don't want to be rude, but we were talking gender roles. I'm a man. I can't do 2 things at once.
Yeah, I already know. Guys in the YouTube stream, just let me know when you see it. It's a depiction of the sun. Looks like a star. Gas molecules between the 2 different telescopes. Just let me know when it pops up.
Yeah, it's up.
Yeah, it's up.
Yeah.
All right, let me take care of another little thing. Little surprise for you out there. How you like that? There's the banana. All right, let me see what we got going here. I want to make sure everyone hears this. Let me turn it up a little bit for you guys out there in the stream. Mic discipline, please. All right, like I said, we're going to allow Professor Vaught from New Mexico State University to speak and hammer my points home. Okay, here we go.
So now that we have the idea of colors going through the spectrum, and of a larger spectrum that contains colors of shorter wavelength or of longer wavelength than the human eye can see, we're going to take those ideas and apply them to spectra, figures or plots showing the dispersed light spread out as a function of wavelength, and we're going to consider the astronomical applications of spectra. So we begin by building on the atomic theory that we developed last week. We know that a given atom of some species will absorb and emit energy at the same frequencies. So if it absorbs a photon at a particular frequency and has an electron jump up 1 or several energy levels, inevitably it will emit the same amount of radiation when that electron decays down towards the lower or ground states within the atom. A cool gas of hydrogen atoms, for example, will produce an absorption line spectrum. It lies between you and your telescope and a continuum light source. So let's think about this and develop this picture a little bit. In our first diagram, on the left we have a white light source, something that emits smooth continuum radiation at all frequencies. And then we have a gas cloud, which is much cooler than the star and is filled with atoms, represented as small circles within the cloud. Our white light source, if observed directly, would produce continuum radiation at all frequencies. But what happens if we look at the star through the cold gas cloud? We know that the cloud is full of atoms. When we say that it's cold, we mean that the atoms contain electrons that are in low energy states, which would just love to jump up to higher energy states. So we see colored beams of radiation coming from the star in all colors, meaning that it's emitting light at all wavelengths or all frequencies. Those photons, which contain exactly the right amount of energy to enable electrons in the gas cloud to move from energy level to energy level, are the ones which are absorbed by the gas cloud atoms. So when we look at the star through the gas cloud, we see a continuum radiation source with light preferentially removed or absorbed at those key frequencies. So this is like a fingerprint. Once you match up the wavelengths that are missing from the continuum spectrum, you know exactly what elements were present within the cloud. Now you may wonder why the radiation is missing from the beam of light emitted from the star when you know that the atoms in the gas cloud will be excited and then de-excited. Let's think this through carefully. The electrons are elevated to a higher state within the atom, and then, given a little bit of time, they decay back down to the lower energy states. So in essence, all of the atoms in the cloud are absorbing and then re-emitting the energy which they take from the star. If that's the case, why doesn't that energy just fill in back the holes in the continuum spectrum, causing us to see a perfect continuum spectrum in our telescope on the right? The answer is very simple. Once an atom absorbs a photon, it loses all of the information about the direction in which that photon was traveling. The electron absorbs the photon, takes that energy to climb up to a higher energy state, and then when it falls back downwards, that photon is re-emitted in a random direction. This is the key point. And the result of this is that the gas cloud emits that radiation isotropically, meaning in all directions. It doesn't send all of the photons back along the beam of the star in the direction in which they were traveling before they were absorbed. Instead, they get scattered in all 4 directions to the winds. We can see this by placing another telescope, one that only looks through the gas cloud but that does not see the star. Imagine that the star and the gas cloud are separated by quite a great distance, as are the telescopes, so that we only see very narrow beams, much as when you look up at the sky, one individual star only covers a very small angular distance from the sky. Now with our second telescope, when we look straight through the gas cloud, what do we see? Well, if there's no strong source of radiation present, if there's no star, we don't see anything. The cloud is cold, remember, and what that means is that it's not emitting energy on its own. The situation gets more interesting when we add back in the source of continuum radiation on the left. Once we do that, our gas cloud has a ready source of energy. It starts to absorb photons and re-emit them, and because it's re-emitting them in all directions, some of them are going to fall into a line that points to our second telescope. We don't see the continuum radiation from the star that passes through the gas cloud. What we see is only the radiation re-emitted by the cloud. So what we see now is an emission spectrum. At most wavelength, there's no energy whatsoever, but at a few key wavelengths, those that correspond to the energy levels of the atom within the gas cloud, we have extra light. If you combine this emission spectrum with the absorption spectrum that we get by looking at the star through the cloud, the combination, in effect filling in the holes in the absorption spectrum with the emission spectrum, leads us to the original continuum spectrum. Light may be divided into 2 paths, but it's neither created nor destroyed in this process. A very elegant process.
Yes, it is. A very elegant process, Professor Vaught. Thank you very much. Because good night, Irene. Everything that I told you up there is exactly what she said. How you like me now? You're not going to. I'm going to tell you that. Key learning objectives. Gases only emit and absorb in bands. That's what she told you also. Right? Yeah. Gas. Not the solid. They call this thing a solid. Unbelievable. Conclusions. Number 1, a belly-laughing bait and switch, equivocation fallacy, terrestrial versus celestial spectroscopy. That's the basis of it. It's fallacious. Number 2, NASA is unsure whether they're getting a continuous or absorption line spectra from the sun. Remember that one. Number 3, these bozos, Hernshaw from Cambridge and Jenkins, Francis Jenkins, think the sun is a solid. Remember that one. Don't forget. And the pièce de résistance. Never forget this. If you don't know or learn anything from the entire presentation, do not forget this. From Lumen Learning, let's do it again. The dark lines in the solar spectrum thus give evidence of certain chemical elements between us and the sun, absorbing those wavelengths of sunlight. Because the space between us and the sun is pretty empty, I think what they're talking about is the space in between Baltard's ears. It's pretty empty. But I digress. Because the space between us and the sun is pretty empty, astronomers realize that the atoms doing the absorbing must be in a thin atmosphere of cooler gases around the sun. We already tore all the rest of that apart. I'm looking at the top line. Thus give evidence of certain chemical elements between us and the sun. What? Give evidence of what again? Well, certain chemical elements between us and the sun. That's not our question. Aren't we attempting to find out what the sun is made of? Not what is between us and the sun? Nice little red herring fallacy away from that, huh? It's real doofus, real clumsy, real proby, real juvenile. right? It's a well duh. This is a joke, folks. It is an utter joke. Can somebody please tell me what the flying Fukuyama is going on here? Please, I want somebody to explain it to me. You better have your ducks in a row. Because it's duck season. Thanks for your ear. Have a nice day. Questions, comments?
Well, a bit of a geeky one. Real question, actually. You're talking about emission spectra of gases, and Dr. we listened to, is it Fukuyama? Talking about cooler gases, and then emission via excitation. Do super duper hot gases behave the same?
Nope. They emit. Now, hold on a second. What's your super hot gases within a container? They will emit in lines and bands.
Now, the point of the question was because it appears, it would seem contentious to me that you would describe any form of gas outside of a ball of gas, which would be really freaking hot because it's right next to that super hot ball of gas, the sun, as a cooler layer. And I think, as I've seen described, there are contradictory layers in the sun's temperature as well, but that would appear to be the explanation for some of the absorption things we see. This cooler, and I've got air quotes up, layer of gas that surrounds that sun. That just seems an impossibility that there would be a cooler.
Exactly. Yeah.
As opposed to a nebulous cloud,
right?
Which is the description, and that's the thing again where you get that misnomer between. I mean, okay, as you said earlier, you forgive the second law of thermodynamics violation that we've got a gas cloud in the vacuum of space, but given that, take it. The point she's describing is it's not emitting on its own; it's requiring excitation of a cooler gas, not superheated, but it's that bit that they're trying to claim is the absorption. It just doesn't. The cooler superheated gas wrapping around the sun seems to be part of the sun, to me, and would be commensurate with its emission. To try and put an absorbing band around it, explain everything, seems nonsensical with the rest of the descriptions, which you presuppose space in the vacuum of it. At least that makes sense, but that bit in of itself, it seems contradictory in their model.
Yes, sir. Everything you said was correct. But like I said, the most important thing to get out of this is that you're asking a question, what is the sun made of, right? But even their fairy tales not answering the question. It's giving you what is what is made up, what it is between us and the sun, not the sun. At best. I hope everyone sees that. That's the game.
That's what I was trying to say. They're pretending can have this effect wrapped around so that there's absolutely apparently nothing that would have this effect. The only effect is that magically that's telling us what it's made of. That just seems nonsensical. If you were going to use this spectroscopy in any way, compare it to the lab. The tube from the sample to the analyzer is protected.
Yes.
So much so that there's absolutely no contamination.
Yes.
What you're analyzing.
Yes.
Okay. And what we've got here is pretense that if we presuppose that the cause of the absorption spectra is this cooler gas wrapped around the sun, and presuppose there's absolutely nothing that interferes over those 93 million miles, we can make a positive declaration that the gas that's emitting a full spectrum, the absorption bits identify what that gas that's emitting a full spectrum is. It just seems it's ludicrous. It's so littered contradiction and nonsense.
It's so littered with contradiction and nonsense. It's nonsensical. That's the best way to describe this. Now, folks, he's talking about celestial or astronomical spectroscopy. He's not talking about the atomic emission and atomic absorption spectrum, which they do in a closed system to tell what substances they are. He's not talking about that one's golden. There's no problems, right? It's only the astronomical one. It's the one that stole the name for the veracity, but doesn't follow any of the principles of the former. Just make sure everyone's aware of that. All right, Betty. I think Adam's had enough. We've been through this a few times. He already knows the deal. I can hear the contempt in his voice.
Yeah, so.
Yeah. I don't know where to bloody start or stop, Betty, with it, because you start on one bit and you think of another issue with it. It's so littered, and hopefully people have got that, but I'll shut up now. But yeah, it is a frustration because it is that hijacking of a very legitimate thing, and then it's used in this most pseudoscience of way. Shocking, really.
Yes, exactly. Betty, we can go through if you want to do it. If you want to take the con and go through everyone on the panel. Doesn't seem like there's a lot of people here. That's a good idea, Baltards. Don't come on in here.
Well, they were here, but said you want to move on, and they left.
Oh, I want to move on, but it was only 5 minutes. I told you. Yeah, don't come in here.
So we got another super chat from Mike, and he says, Mike 808 says, How is it going? It's sort of a sticker.
Ah, okay, thank you. It's going really fine, as you can tell. Not too well for the Baltards. See, what happens here, around 4 and 6 months, they'll start talking about spectroscopy again. And when I hear it, I just make mental notes, mental check marks, right? And when it gets to a certain number, and that's right around 4 to 6 months, then my presentation comes out. Again, that's the way I do it. Then you won't hear about it for another. It's a cycle. It never ends, right? That's how I conduct business. So hopefully the people that hear this today has got a grasp on it. I've taught on it like 3 or 4 times now. You're gonna hear it again next week. So get ready, and hopefully they'll bust the people talking about spectroscopy. That's the mission. Not only to know this stuff, but when you get challenged with it, when they just spectroscopy, right? You just hammer them with that one point. You don't have to go through all the points that I went through. I just wanted to give you some background with the convoluted nature of this monkey. The one point. They are not in the best case scenario. Even if it was legitimate, everything was legit. They're not looking at what the sun is made of. They're looking at what's in between us and the sun. That's what I want you to remember for this. So go ahead, Betty. Sorry. You can go down the list if you like.
Yeah. Let's go to Dawn. I'll unmute you. Have anything to add? Questions?
Awesome show, man. Like it, QE. Yeah, I've been talking about that over at Jim's for a while. What's between, stuff like that. But nice show, man. Appreciate it.
Thanks.
And we got a person named Firefly.
I know her.
Okay. It's a her.
It is a her.
Aha.
Aha.
Maybe she wants to shed some light on this too. Firefly? You there?
She can't talk. She said sorry she can't talk, but hello. That's Leluca.
Would have been nice to hear another female voice here.
Yeah, I'm sure you're yearning for that. She said, keep up the good work. I will. Thanks, Leluca. Appreciate it.
We try Flat Arthur again.
Flat Arthur, I put you on mute because your mic was back feeding. And it still is.
Ooh, that's loud.
I'll unmute only when I speak.
You're fine. I was going to tell you that. I was waiting for it to get to you anyway. How's it going, sir?
Doing fine, sir.
I can see he's laughing when he says, sir. You can hear the laughing, sir. So any questions, comments that come to your mind with this?
No, sir. I watched your spectroscopy presentation from like 4 or 5 years ago in what was Cathexis's channel. Yes.
Oh my! You were back there?
No, I later on, like last year, I listened to all of them.
Oh,
presented.
Gotcha. Cool. Okay.
Yeah, he still got some up. Oh, that's good.
Yep.
That's your earlier work. Huh?
Yep.
Yeah, it's still actual. It's still good, right?
Yeah, that those presentations weren't that much different. Nope, not at all.
Yeah, you tweaked them a little bit because people came up with new stuff from Wiki.
Yeah, I guess there's a little tweaks here and there, but for the most part, pretty much the same. Yep.
Yeah.
Well, I have something unrelated, if I may.
Not unrelated.
Okay.
Okay,
I'll
so
keep it for later then.
you have to.
Hold on a second, Betty. If it's unrelated, can you type it in BALLBUSTERS live stream for us?
I mean, it's regarding radar.
It's regarding radar.
Yep. How using radar we can calculate the distance to the moon.
Did you see? Let me point you to Bouncing Biscuits. Oh, I forgot to hit the numpty clips. Are you watching the numpty clips?
Sure, sir. I enjoy them a lot.
Then you already know the answer to this question. Go to Bouncing Biscuits.
Okay, I may have missed that one.
Go on to the playlist, folks. Don't be missing these numpty clips. I'm telling you, there's great information. Not only the thumb in the eye. Yes, I take some liberties and use some artistic license. But, however, there's some good education in there. So, Flat Arthur, go right there to Bouncing Biscuits, and it'll answer any question you have. And if it doesn't, then just PM me.
Sure, sir. Thanks.
Yep. There's some more coming out on that subject too, but it's bouncing radar off the sun. Hold on, boy. It's coming. I don't know when it's coming, but it's coming.
It actually came up in a debate of Nathan Thompson with Tom Jump on Modern Day Debate, which is why it was there in my mind.
Oh, it did. Was it just with the moon or the sun? Or
the moon, thankfully. They were not talking about radar calculating the sun. It came to that point, but somehow they did not discuss it.
Okay. Yeah, they used the same little ploy with the sun.
Yep. So I have had that discussion otherwise with people in India that I talked to who were talking about Kepler and he using the equation. So I just asked them, how did he know the distance to the sun? So the answer was, we have technology that we can bounce light off the moon. So I was like, hello, we are talking about the 1500s and the 1600s. What are you saying? We can bounce light off the moon. And even then we are talking about the sun. How are you going to do that with the sun?
Oh, there's another peccadillo with the sun. Just be patient. It's coming, I promise you. But the moon one is Bouncing Biscuits. It's paid NASA shill. That numpty. It's good. You'll like it, Flat Arthur. It destroys it.
Okay, it's that one with paid NASA shill. Okay,
Yep, the title is Bouncing Biscuits. Can't miss it.
got it.
All right, Free Palestine.
There.
Yep.
Yeah.
What, we're going back to my question?
I don't think it's a question at this point. Yeah, you're right. So go ahead. You can ask it again. So just somebody might have missed it.
Yeah, I was just saying or asking that how do they account for atmosphere between the telescope and the sun? Right? Earth's atmosphere, that is, not the sun's.
That's a great question, man. I don't think I'm the one that should answer that.
I think that I alluded to earlier. Historically, Sophia would be the thing. Strap a telescope to a high altitude plane, try and get observations like that. That still has its limitations because there's still atmosphere there. Hence, the purpose of Hubble was to go outside of that atmosphere so that the optical stuff they were trying to get didn't have that interference. It's kind of an admission, isn't it? What QE was saying with regards to real spectroscopy. Yeah, that we have to isolate any other input if we're going to be able to analyze. There's a recognition there, hence going higher in planes, reducing the amount of atmosphere, hence Hubble. What have they done? Like I said, break the Hubble, didn't they? Hence why hard-working people who had been going up there in planes had an objection when they saw the data and said, that's our bloody data. You just manipulated it a little bit. So I think from an early age, they realised, yeah, hence why telescopes are put high on mountains, because it reduces the overall amount of atmosphere that interferes with what you're looking at. I think there's a recognition there. You're just not allowed to question it with regards to terrestrial spectroscopy. Still works.
Still.
Also,
go ahead.
If you actually believe in astronomical spectroscopy, wouldn't you come to the conclusion that the sun is a solid in that sense?
It's the logical inference, isn't there, from what we know here that we can prove with regards to gas behavior, solid behavior, and emission spectra. And there's that contradiction with what they claim that thing that's producing a solid emission spectra up there is made of.
Good.
Astronomical spectroscopy. That's a mouthful.
Yeah, I know. I was gonna say. I was thinking that same thing when you said it. I said, say that 3 times real fast.
I've had a couple of shandies. I was surprised it came out clean the first time. It did.
All right, Neil.
I'm good. I don't have a question, but I think my wife has a question.
Really?
She's giving me fire right now in her eyes. Oh, no.
Tell her at least he's going to be intelligent this time then, Neil.
Yeah. Kiwi, I wish I could have been in that classroom. It must have been like, this old freaking guy is going to keep us here longer than we want to be here.
Yeah, I guess old is relative, right? I was only 28 at the time.
Yeah, but I was hanging out with a younger crowd at 21. They were only 18, and they called me old man.
Yeah, right. Yeah, that's true. Yeah, so it was...
To be frank, QA, I'd have hated you because you'd have kept me from the Union Bar.
Yeah.
You little nerd.
You little nerd. Yeah, so it wasn't just 28. It was, I think, 27, 28, 29, 30, 31, those ages.
Let me ask you another question. When did you start coming to a realization of, let's just say, the gas pressure out of container?
Oh, I told you when I was challenged with it. That was in May of 2016, probably the first week of May.
But then before that, it like didn't even phase you, correct?
I never thought. Thanks for bringing this up, Neil. I appreciate it.
No, because I'm trying to understand it. You know, as far as guys that had the minds, like the trick was so elaborate that nobody even caught on to it. I'm not trying to put you down, QE. I hold you very high, like the highest.
No, I mean, you're right. I'm going to tell you, I never thought about it. To be perfectly honest with you, I never thought about it. I was concerned, you know, with life's troubles. It's not an excuse. I just never focused my attention that direction. The subject never came up. It's just one of those things that just, you know, went underneath the radar.
That's what I'm saying. The trick was so elaborate, it just slipped right by everybody.
Yeah, it didn't slip by. It was it can't slip by if you're not looking for it. In other words, you know what I'm saying?
Let's say it was covered up then. It was in a way, because I can't believe that nobody thought about it, because it's so obvious now when you bring it out.
Right.
But like, however they designed this whole thing, I mean, it's just something that wasn't paid attention to, I guess. Or like you say, thinking of other things, not even like thinking like, whoa, how can we be a sphere? And how could that be infinite space? Where's the container?
Yep.
I was the same. I had experience of gas pressure. It's kind of the like when you're a kid at school. It's the tacit acceptance of, even though you don't, you stick them away, and one on its own doesn't really matter. But lots of them put together enables them, unbeknownst to you, them to build this paradigm, and all of these little contradictions that come together, and eventually. Mine wasn't this one. Like I said, even though I have gas pressure knowledge, you know, containers, but it's something as simple as realizing that if you burst a balloon, the pressure in the balloon doesn't stay there just because the container's gone, that it goes, it disperses. And it is fundamentally something as applying that basic knowledge to reality that snaps in your head sometimes. But it's so well done and so well rebutted in your primary education that you can get to that point that you accept that knowledge, even though actually all those fundamentals, the seven housekeeping questions, they summarize it, but you accept each one on its own and move forwards because they're in different disciplines. So the veil persists, and it's only when you get that eureka moment that John describes that, oh my God, why was I mugged off like that? That is just so ridiculous. And this frustration at yourself then, I don't know about you, John, there's oh my God, was I really that stupid? How could I have not seen that before?
Yeah. Yeah, I spoke about it many times. Yep, it's just one of those things. Like you said, there's a tacit, you explained it, you're right on point. There's a tacit acceptance, right?
Alcoholics call it a moment of clarity, don't they?
Yes, they do. and who would know better than you?
Oh, well, exactly. You see, I like to draw an analogy from my own life. You know, it's all the more powerful. But it is like that alcoholic moment that you go, oh my God, I had all this knowledge, yeah, but I've never applied it to the world. How do I keep that together? And it is a power moment for me when you have those. Mine was more with biology, but
right.
And the create, you know what I mean? And but there's got to be something that's you're awakening that makes you go, you're getting lied to. Hello, it's so obvious to you and your personal knowledge. you can't deny it anymore. Your subconscious can't deny it. It can't allow the fact that your teacher said, "Don't be silly, little John. Of course you're upside down in Australia." No. It's that. It comes out, doesn't it, eventually? And that, to me, are those challenges, because I love space. But I understood gas pressure, make aerosols. Do you know what I mean?
Yep, sir. Betty.
What up?
What up, homie?
We got one left here that hasn't talked, I think. Oh, and the one up top again. Runs with scissors?
Yep, no microphone, but there's some guy. Yeah, we don't care about him.
Weren't we getting a question from Neil's wife?
That's what I thought.
Neil.
No, I was only kidding. I wanted to see if she would ask a question. She just turned red and looked at me with fire in her eyes.
You probably just want to ask him out.
I wasn't ready for that. That's really good. I definitely.
That was a good one, Betty. She wants to say hi.
Hello.
Hello.
Hi, Betty.
Hi. Sorry, I had to make a joke on your account.
So here's your lady voice that you were dying for.
Yeah, now I'm happy.
Thinking of you, Betty.
Oh, she's a nice voice. Nice to hear. Nice lady.
Forget about it.
She knew what you were talking about. What are the drinks you called them? Shandies?
Oh, Shandy.
Yeah, she knows what they are because she's from Guyana. So a lot of the English and Irish stuff, she knows about. Like, you guys like curry.
Oh,
They're
well,
big on curry.
Right.
I guess because they colonized over there, right?
Guyana or Ghana?
No, Guyana.
Guyana.
South
Only because
America,
I had sweet balls today. My Ghanaian I did. Oh, tough, mate. I know I'm going back to food again. Yeah, so similar drinkings. Shandy. So Shandy's like a bitter or lager and splash of lemonade. That was a colloquial use.
Yeah, I had no clue what you were talking about.
You know. Let's just see what's her name, because she must be as strong and supportive lady as my Marie, mate. If she can put up with flat earthers and then give you the eyeballs when you go. That's gonna go on.
Oh no, she's on the flat earth side. She realizes biblical cosmology. That's for sure.
He asked.
In the Bible, it's true. That's it.
He asked what her name was.
Oh, I didn't hear him. Outside here. Her name is Serena.
Oh, that's a nice
Evening,
name.
Serena.
No, not Serena. Not Serena, the teenage witch. Sarita.
That's Serena.
Sarita. Sarita.
Sarita.
Yes.
Now you've pronounced it correctly. I can hear it. Good evening.
Translators here.
It's the Brooklyn accent.
He's thrown some friggin' volleys over at Neil. They're real subtle at him. I really like it. He hasn't caught on yet.
I
don't really teasing him. He hasn't, has it?
Adam says, you think I'm like a piece of wood? I got him. I just like Adam.
That's why I'm teasing you, you see. It's this humor, my friend.
Yeah. The one you missed, Neil, is Adam asked for your wife to ask a question, and he said something to the effect, I'm paraphrasing, at least it'll be an intelligent one this time.
I heard him.
I know you didn't buy. Nathan spotted it in chat, but I was disappointed. I was only trying to wind you up.
That meant get by me.
It was a backhanded compliment to your wife, obviously.
Yeah, I'm sure.
Hey, you're on the debates, and I said it flippantly. You're on the debates a heck of a lot, and whatever we do, others that give a lot of time, we wouldn't be able to do it without the support of our spouses. And I've done it many a time. I love Marie to bits, and thank her for letting me be here now while she's been out making noise, loads of noise outside while I was trying to talk. Yeah, but I couldn't do any of it without her support of doing so.
Shout out to the ladies.
She's probably looking over your back shoulder, right, Adam?
What, mate?
She's probably in the neighborhood, so that you could say that, huh?
She's probably too far away for me to get any plaudits, if I'm being honest. 10 minutes ago, she was.
Yeah.
See, Adam, I'm a man of many abilities. Right now, I'm playing Frisbee with my 50-year-old. Took my wife to the mall. Now I'm back. Frisbee walking.
How far can you throw a Frisbee?
What's that?
How far can you throw a Frisbee?
Oh, I'm nice with Frisbee. Very
There's
nice.
a mall and back.
I don't do the back throw, like you swing your body this way. I turn to my right side and with my 2 fingers hold it and throw it like I'm throwing a sidearm. And it goes.
Can
like
you do a chicken wing? Can you do a wingy?
Wingies.
What's that? Oh, wingies. Uh-oh.
You throw it like backwards and flip it over so your arm looks like it's a chicken wings one. I saw a YouTube video. That's really weird.
Yeah, I know what you're talking about. Yeah, I can do that.
I was trying to bring it back with a wingy, you see.
It was a good try. All right, guys. Any other questions, comments? Betty, I'm getting an echo, probably from Adam.
That's that question from Slit I'm still waiting for.
You want to go to other people, or you want to round out?
No, go ahead. Did somebody else join? Mark Nurse 2, I think it is?
Yeah, we got Chet Farrow first.
Okay.
Chet Farrow?
Hey, yeah, I came in late, so I was just catching up on the discussion.
Cool.
But I'd love to share next time.
Okay.
Okay.
Thank you.
Yep, you're welcome.
All right. And then we got Mark Nurse 2. I don't think that he was here earlier, but got to say. You're muted?
Hello, can you hear me?
Yep.
Just a quick one about the gas pressure, about the container.
Mm-hmm.
All right, just stay with me now. You got a horizontal bar, a string attached to a piece of wood, which is also horizontal. Then you tie 2 strings to a balloon and you fill them up with air. And then what would happen if you pop one balloon?
Not following.
So I'll say it again. You got a horizontal bar, string down the middle of the horizontal bar, attached to another horizontal wood. Then you attach 2 balloons, which are blown up with air, filled with air. And what would happen if you burst one of the balloons?
What would happen?
Yeah, what would happen?
You mean with regards to the pivot point?
Yes, perfect, yes.
Well, then assuming that those balloons were given an equal would pull, so that the balance beam was equal at the point before popping, and one side would have that would pull, so you would expect a movement. I'm not sure how it relates to gas pressure. It's more to do with density and buoyancy. Pressure directly. But yeah, one side, assuming that had a upward pull and it was a free pivot, you would expect a movement in the previously balanced beam.
So one side will swing to the other side, correct?
But yeah.
So one side will, obviously, it'll swing to the other side, wouldn't it?
You've created a disequilibrium, haven't you? Where previously there was equilibrium. But it's based on the premise that equilibrium is supported by an upward thrust of the balloons. They're not just hovering there with the slack string, they're applying a force upwards to balance on the pivot, yeah?
Yeah, correct.
The reason why I bring it up because,
but then that would have the contradiction that it's supported by a downward string. Isn't it?
yeah. Reason why I bring it up because I saw it in a kids' Key Stage 2 science book, and I saw it, and they said, obviously, if you do this experiment, they said it was an experiment, and you pop one balloon, what do you think will happen to the other side? I just wanted to get your take on it. For me,
presumption,
go on.
You've got the upward lift, haven't you? If you presume that, but in reality, you've assumed pivot. But because your pivot is created by slackness in string, just like slackness in string, in reality, it's going to do nothing, isn't it? Because the net downward fall. I don't work it out, but that would seem the logical thing because you can't apply an equilibrium. Net upward force has to be negated or ignored.
Yeah, I agree. Yeah, 100%. Yeah, I just thought I'll bring that up because I just saw it and I thought, let me just say it, as it relates to gas pressure, in a sense.
No, it was naughty, and you should give me respect for taking that on the fly.
It was naughty.
Yeah, but
it's a trick question, isn't it?
You said what I thought you would say.
It is. It's a trick question because the premise is to ignore. It's like standard baller tactics. Get the dirty shit out at the beginning. It's a very good example of it. Get the dirty detail out at the beginning, so you move on, and you forget that the initial pivot point is made of a string, and you work with the pivot point from there, which is probably what my thinking was as you heard it. Trick question.
Yeah, and that's what they're trying to teach children in year 5 and year 6 to think about things like that. But of course, if you obviously put the pin in one of the balloons, of course it's going to swing because, like you said, disequilibrium. Obviously, one's been popped. Of course, all the air is going to go the other way, the other side, isn't it?
You would expect a lateral side-to-side movement because of air distribution, but not a up and down directly because of a differential in the seesaw. You know what I mean?
Yeah, correct. And I thought it
lead
was
you into that route. Yeah.
Yeah, I thought it was a silly experiment to put inside a book to get children to follow and agree with that. Yeah, that's why. Yeah, I brought it up. Thanks.
I think it's a good question because I'm bottling half a wine down and it nearly had me. Nearly, but it nearly had me.
I didn't see it. I didn't see it. I didn't see the question. No.
I've got a book. I've got the book. I'll take a picture and I'll send it.
That'd be better. Yeah, I'm highly visual, man.
Send it to you.
Yeah,
I'll send it to you.
Yeah, cool. All right. Anything left, Betty?
Yeah, I got one last super chat to shout out. It's Flat on Flat Earth. It says, great show. Thanks, Kiwi.
You're very welcome, sir. All right. Final thoughts for Betty, and we're going to wrap things up. Put her on the spot. Yeah. Final thoughts on the presentation, not final thoughts, because we'd be here for another 3-4 hours.
Yeah, it could be. Yeah. In case I wanted to have my 10,000 words out.
Exactly.
Yeah, those were the beginning of them. Yeah, you did a great presentation. I think it's very clear for new people to come in, and they can also go back to the more elaborate ones that you did before, right?
The elaborate. Which ones you talking about?
Yeah, I think you did one on Ballbusters too. I think one on where Davey, John D was also present, right? He was a guy that works with spectroscopy. So good show too back then.
Yep.
Yeah. Yeah. I mean, it's all a fairy tale, right?
Yes.
So unless that we sort of do know, we know that we don't know anything, right?
No.
Oh, I mean, we still don't know what the sun is.
Oh, well, yeah, there's some things out there that we're just never going to know. It's just not going to happen. I agree with that. Sure.
Yeah, but we ask these questions, we find out a lot, but it's not doing the thing that we wanted to do.
Well, it seems that other people have the answers. Of course, they don't know what they're talking about. That's the point of this presentation, is to expose pretender clowns systematically. It's not a nuh-uh. Why go systematically, point by point, and just deconstruct it? That's the point of it.
Well, you know,
what we do learn is what, as Bob Bay said, we do learn something because we learn what it's not. Don't we? We learn it's not a big ball of gas.
Exactly.
3 million miles away. So we can knock that one off the list. I mean, this, as Bay says, there's still a long list of things out there that it could be, but we've knocked one off. At least tonight, so.
Yeah, that we did.
Yep.
Oh,
okay.
Thing, because we're getting spammed in chat. Please mention Nathan's show, which is probably finished by now. But
yeah, we need to shout Nathan's show now. Yeah, going to have.
They're expecting a pop-in day.
FED 1424 20K special GoFundMe update show soon.
Is it going out now?
It doesn't say.
Oh, he did. Probably because he knows that we're gonna round it out. Yeah, I'm going to right now. Thanks, guys. Appreciate it. And for everyone out there, like I said, this is ammunition against anyone who just flippantly brings up spectroscopy. Not only the background information for you guys to understand, but if anyone brings it up, you could just deconstruct them. Listen to this video a couple times. Just go with the main points. Don't worry about the little garnishes before the main point. The main point is that their fairy tale can't tell you what the sun is at its best, at the very best, even if it was legitimate. It doesn't tell you what the sun is. It tells you what's between you and the sun, the gas between you and the sun. That's as best as it can do. Also, keep an eye out. We got the numpty clips this week. A couple good ones left. We got Hillbilly Blue Balls, Redneck Retard, a.k.a. the Photosynthetic Redneck, just gonna hammer away at the C4 fire. It's pretty funny. Thanks a lot for that one, Hillbilly Blue Balls. And we got the PhD Booger-Eating Schmuck, M. Scott Veach, and his sidekick, Shamalama Gamba Panda Ding Dong, to wrap it up on Thursday. So stay tuned, man. These things you're going to enjoy them. Let me just tell you that. And next week might be a couple surprises out there with the numpty clips. But I haven't thought about that too hard yet. But keep your ear to the grindstone. So, take no prisoners. No quarter will be asked. None shall be given. And remember, I'll be back.